Yes, that approach is generally correct for calculating the electrical load for a mixed-use building with both residential and commercial spaces. Firstly, for the residential units, calculate the electrical load for the 7 residential units according to standard residential load calculation methods. Consider factors such as the number of occupants, square footage, and typical appliance usage. Secondly, for the commercial space, which is the grocery store, calculate the electrical load by identifying and adding up the nameplate ratings of all fixed appliances and equipment, such as freezers, refrigerators, lighting, and any machinery used in the operation. Also, consider the operating hours and usage patterns of the grocery store to adjust the load calculations accordingly. There are additional considerations that need to be taken into account. Firstly, shared spaces. If there are any shared spaces between the residential units and the grocery store, such as hallways or common areas, you may need to allocate a portion of the electrical load to each space based on usage. Secondly, demand factor. For commercial spaces, it is important to consider the demand factor, which is a multiplier that accounts for the expected simultaneous use of multiple appliances or equipment. Thirdly, code compliance. Ensure that your calculations meet the requirements of the applicable electrical codes and standards, such as the National Electrical Code or local regulations. Next steps. Once you have calculated the electrical load for both the residential units and the grocery store, you can firstly determine the total load for the entire building. Secondly, design the electrical system to meet the calculated load, considering the appropriate voltage, amperage, and circuit requirements. Thirdly, consult with the local electrical utility to coordinate the elimination of one service and the upgrade of the remaining service to meet the new load. By following these steps, you should be able to accurately calculate the electrical load for the mixed-use building and ensure that the electrical system meets the needs of both the residential units and the commercial space. Let's delve deeper into the specifics of calculating electrical loads, focusing on the National Electrical Code (NEC) as a primary reference. When dealing with residential units, the NEC provides guidelines for calculating the general lighting load based on the square footage of the dwelling. You would typically use a value of 3 volt-amps per square foot as a starting point for the general lighting and receptacle load. This value is outlined in NEC section 220.12. For the 7 residential units, you would calculate the square footage of each unit and multiply it by 3 volt-amps per square foot. The NEC also requires you to account for small appliance branch circuits and laundry branch circuits. NEC section 220.11 requires a minimum of 2 20-amp small appliance branch circuits for the kitchen and dining area, and at least one 20-amp laundry branch circuit. Each of these 20-amp circuits is typically calculated at 1500 volt-amps. Therefore, you would add 3000 volt-amps for the small appliance branch circuits and 1500 volt-amps for the laundry branch circuit to the total load calculation for each residential unit. For dwelling units, you must also account for any fixed appliances such as electric ranges, ovens, cooktops, dryers, water heaters, and air conditioning units. The NEC provides specific rules for calculating the load of these appliances. For example, NEC Table 220.55 provides demand factors for electric ranges, ovens, and cooktops based on the number of appliances. The demand factor reduces the calculated load to account for the fact that not all appliances will be operating at their maximum rating simultaneously. For electric dryers, NEC section 220.54 allows you to apply a demand factor of 75% if there are 4 or more dryers. For air conditioning and heating equipment, you must use the nameplate rating of the equipment to determine the load. NEC section 440.6 provides guidance on calculating the load for air conditioning and refrigeration equipment, requiring you to use the nameplate rating for the compressor and any other associated motors. Now, let's move on to the commercial space, which is the grocery store. Calculating the electrical load for a commercial space is typically more complex than for a residential unit because of the wide variety of equipment and appliances that may be used. The NEC requires you to calculate the load for each piece of equipment based on its nameplate rating, which is the maximum power consumption of the equipment. For the grocery store, you would need to identify all of the fixed loads, such as freezers, refrigerators, lighting, and any machinery used in the operation. You would then add up the nameplate ratings of all of these loads to determine the total connected load. For refrigeration equipment, NEC Article 440 provides specific rules for calculating the load. You must use the nameplate rating of the compressor and any other associated motors, and you must also consider the operating IOs and usage patterns of the equipment. For lighting, NEC Section 220.12 provides guidelines for calculating the lighting load based on the type of occupancy and the square footage of the space. For a grocery store, you would typically use a value of 1.25 volt amps per square foot for general lighting. However, you may need to increase this value if the store has a high level of lighting, such as for display cases or specialty lighting. In addition to the fixed loads, you must also consider any receptacle outlets in the commercial space. NEC Section 220.14 specifies that each receptacle outlet is to be calculated at 180 volt amps unless the actual load is known. You must also consider any electric motors used in the operation of the grocery store, such as for pumps, fans, or compressors. NEC Article 430 provides specific rules for calculating the load of electric motors, requiring you to use the nameplate horsepower rating of the motor and the corresponding volt-amp value from NEC tables. As mentioned earlier, the demand factor is an important consideration for commercial spaces. The demand factor accounts for the fact that not all of the equipment and appliances will be operating at their maximum rating simultaneously. NEC Table 220.42 provides demand factors for various types of commercial occupancies, including grocery stores. The demand factor for a grocery store typically ranges from 50% to 70% depending on the size and type of store. You would multiply the total connected load by the demand factor to determine the maximum demand load, which is the maximum amount of power that the store is expected to draw at any one time. When calculating the electrical load for a mixed-use building with both residential and commercial spaces, it is important to consider any shared spaces, such as hallways, common areas, or parking lots. You may need to allocate a portion of the electrical load to each space based on usage. For example, if the residential units and the grocery store share a common hallway, you would need to allocate a portion of the lighting load to each space. To determine the total load for the entire building, you would add up the calculated loads for the residential unit, the grocery store, and any shared spaces. You would then use this total load to design the electrical system, considering the appropriate voltage, amperage, and circuit requirements. It is important to consult with the local electrical utility to coordinate the elimination of one service and the upgrade of the remaining service to meet the new load. The utility may have specific requirements for the electrical system design, and they may also be able to provide guidance on energy efficiency measures. Now let's elaborate on some key aspects of electrical load calculation for the mixed-use building. We'll delve further into demand factors, diversity factors, and specific NEC articles to ensure a comprehensive understanding. Demand factors are crucial in determining the actual load a building will experience. They recognize that not all electrical equipment operates at its maximum rated capacity simultaneously. For residential units, the NEC provides demand factors for various appliances and loads. For example, NEC Table 220.55 provides demand factors for household electric ranges, wall-mounted ovens, and counter-mounted cooking units. These demand factors range from 80% for a single range to as low as 8% for more than 6 ranges. Similarly, NEC Section 220.53 allows for a demand factor of 75% for 4 or more fixed appliances fastened in place on the same premises, excluding ranges, air conditioning, space heating, and clothes dryers. For the grocery store, demand factors are even more critical due to the high concentration of electrical equipment. NEC Table 220.42 provides demand factors for non-dwelling receptacle loads. These demand factors vary based on the type of occupancy and the total calculated load. For a grocery store, you might also consider demand factors for refrigeration equipment. While the NEC doesn't provide specific demand factors for refrigeration, industry standards and engineering practices suggest that a demand factor of 60% to 80% is reasonable, depending on the size and type of refrigeration equipment. Diversity factors are similar to demand factors but are applied to groups of loads rather than individual loads. A diversity factor recognizes that different types of loads will have different peak demands at different times. For example, the residential units may have peak demand in the evening, while the grocery store may have peak demand during the day. By applying a diversity factor, you can reduce the overall calculated load for the building. The NEC does not provide specific diversity factors for mixed-use buildings. However, you can use engineering judgment and historical data to estimate a reasonable diversity factor. A common approach is to analyze the load profiles of the residential units and the grocery store and determine the degree to which their peak demands overlap. Based on this analysis, you can apply a diversity factor to the combined load. Now let's discuss some specific NEC articles that are relevant to electrical load calculation for the mixed-use building. NEC Article 220 provides the general requirements for branch circuit, feeder, and service calculations. This article covers topics such as general lighting loads, receptacle loads, appliance loads, and motor loads. NEC Article 430 provides the requirements for motors, motor circuits, and motor controllers. This article covers topics such as motor nameplate ratings, motor overload protection, and motor short circuit protection. NEC Article 440 provides the requirements for air conditioning and refrigeration equipment. This article covers topics such as compressor nameplate ratings, branch circuit protection, and disconnecting means. NEC Article 310 provides the requirements for conductors for general wiring. This article covers topics such as conductor ampacity, conductor insulation, and conductor sizing. In addition to the NEC, you should also consult local electrical codes and regulations. Local codes may have additional requirements or modifications to the NEC. It is important to comply with all applicable codes and regulations to ensure the safety and reliability of the electrical system. Shared spaces between the residential units and the grocery store require careful consideration. Common areas like hallways, lobbies, and parking lots need to be accounted for in the load calculation. Determine the square footage of these shared spaces and apply the appropriate volt-amps per square foot value from NEC section 220.12 for general lighting. Also, consider any receptacle outlets in these shared spaces and add 180 volt-amps per outlet, as specified in NEC section 220.14. If the shared spaces include any equipment, such as HVAC systems or elevators, calculate the load for these systems based on their nameplate ratings. Allocate the load for shared spaces between the residential units and the grocery store based on a reasonable allocation method. This could be based on the square footage occupied by each occupancy, the number of occupants, or the usage patterns of the shared spaces. Now, let's talk about practical considerations for upgrading the electrical service to the building. Before upgrading the service, it is essential to conduct a thorough inspection of the existing electrical system. This inspection should identify any existing problems, such as overloaded circuits, undersized conductors, or damaged equipment. It should also assess the condition of the existing service equipment, such as the service entrance conductors, the main disconnect, and the panel boards. Based on the results of the inspection, you can determine the scope of the upgrade. This may involve replacing the service entrance conductors, upgrading the main disconnect, adding new panel boards, or rewiring existing circuits. It is also important to coordinate the upgrade with the local electrical utility. The utility may have specific requirements for the service upgrade, such as the size and type of service entrance conductors, the location of the service equipment, and the metering requirement. Once the service upgrade is complete, it is essential to thoroughly test and inspect the new electrical system. This testing should verify that the system is functioning properly and that it meets all applicable codes and regulations. It should also include a load test to ensure that the system can handle the calculated load. The electrical service upgrade should be performed by a qualified and licensed electrical contractor. The contractor should have experience in performing service upgrades and should be familiar with all applicable codes and regulations. The contractor should also be able to provide documentation of the upgrade, such as electrical drawings, load calculations, and inspection reports. Remember to maintain accurate records of all electrical work performed in the building. This documentation should include electrical drawings, load calculations, inspection reports, and maintenance records. This documentation will be valuable for future maintenance, repairs, and upgrades. Consider implementing energy-efficient measures in the building to reduce the electrical load. This could include installing energy-efficient lighting, using energy-efficient appliances, and improving the insulation of the building. Energy-efficient measures can not only reduce the electrical load but can also lower energy costs and improve the comfort of the building. In summary, calculating the electrical load for a mixed-use building with both residential and commercial spaces requires careful consideration of various factors, including the square footage of the building, the type of occupancy, the appliances and equipment used, and the applicable codes and regulations. By following the steps outlined in this discussion and consulting with qualified professionals, you can accurately calculate the electrical load and ensure that the electrical system meets the needs of both the residential units and the commercial space. Always prioritize safety and compliance with electrical codes throughout the process. Remember that the NEC is a living document that is updated regularly. It is essential to stay current with the latest edition of the NEC and any applicable local codes. Continuing education and professional development are crucial for electrical professionals to stay informed about changes in the industry and to maintain their skills and knowledge. Finally, remember that electrical work can be dangerous. Always take appropriate safety precautions when working with electricity and never attempt to perform electrical work unless you are qualified and licensed to do so.